Hello, I'm Christian Fanley Ramsey.
And I'm Haohan Wang. Together we make Diet Ex Machina. And our focus area is at the intersection of deep learning and psychophysiology.
And that means we focus on two areas. The first area is looking at current technology, current intelligent machines, and giving them the ability to understand a user's psychological state. So that might mean the mood or how they're handling stress at the moment. So intelligent machines can act more accordingly to how a user is feeling at any given moment in time. The second area that we're focused on and that we're more passionate about is we're focused on applying this same deep learning technology on classifying people's mental states, but then surfacing that to them so that they can be more emotionally aware and resilient.
I'm a deep learning researcher. As I mentioned, my focus area is using machine learning to process psychophysiological signals over time to understand and provide support for people's emotions and well-being.
And I'm an applied data scientist at IDEO. I currently work out of Greenfield Labs, which is a collaboration between Ford and IDEO working on the future of mobility. I, like Haohan, am very focused on processing people's psychophysiological signals using deep learning and other machine learning technologies to make sense of how we feel and act towards our stress responses and to make us more resilient.
We will be your guides through this course. In this course, we will be teaching you how to solve various deep learning problems using Keras, TensorFlow, and Google Cloud machine learning engine. More importantly, we're here to give you the skills that are required to handle large volumes of data and complex neural network architectures using distributed techniques for production-level systems.
We could offer an example. So if you think of autonomous vehicles, there's these levels of autonomy. In level 3 autonomy, we're still having the driver, the human driver, take over when the computer vision model determines through the surrounding environment that the conditions are too dangerous for it to continue, and it hands over the wheel to the human driver. Now, we've done a really good job of taking in the external environment in the set conditions such as weather and the road conditions. But we haven't done much on the front of understanding the human driver's internal states. So let's imagine that we're streaming in the heart rate, we're streaming in the electrodermal activity, we're streaming in the skin temperature of the driver, and we're using those signals, and we have a deep learning classifier, probably a recurrent neural network, that allows us to understand over time if the driver is agitated, tired, happy, or excited. And then we were able to use that classification and build it into another model that determines if the driver should take over or not. Now, in order to do that, we need to be streaming in that data in real time and making those predictions very, very quickly. They would have to be very robust. So in this course, we're going to help you build the skills to scale out your deep learning models and use distributed techniques using Google Cloud's ML engine that will help you solve for use cases like the one I just mentioned. So let's talk more about the prerequisites of the course.
In order to take this course, you don't have to know how to do distributed deep learning or even have trained on a GPU. This course will be somewhat accessible to those who are new to machine learning, but we believe it will be the best for those who have experience with training and evaluating machine learning algorithms. This includes titles like data scientist, data engineer, and machine learning researcher.
So let's dive into the content of the course. This course consists of 4 sections. The first section will be the setup section, where we'll help you get your machine set up to do distributed deep learning and also install the tools you'll need to do the rest of the course. Haohan will take you on a deep dive into the basics of deep learning using TensorFlow and Keras. From there, Haohan will take you on a deeper dive into low-level TensorFlow. where you'll design the computational graph directly and use distributed techniques. From there, in final section, we'll take all that we've learned and do this basically the same thing, but do it in the cloud in a much faster way and eventually deploy our model as a production level API. So let's talk about each section in detail. In the setup section, the first thing we'll do is get the local GPU that you have on your laptop or machine set up for distributed deep learning. We'll do so by installing the correct NVIDIA display driver. We'll install CUDA and QDNN, and from there we should have our machine set up to use the GPU. Now what we'll want to do next is install Anaconda, which is a data science distribution, which is a collection of Python packages that we'll use throughout the course. We'll use Conda, which comes from Anaconda, which will allow us to create an isolated environment on our machine so we can install all the packages we need and also freeze certain packages that we want to stay the same. So the first thing we'll do, after that we'll install TensorFlow GPU, Keras, and Google Cloud ML tools. By the end of the section, we'll have everything that we need to use our local GPU and also do the rest of the course.
I will be teaching you the basics of deep learning, and we will be using a high-level deep learning library, Keras. After getting you up to speed, you should be able to design and experiment with any typical deep learning models using Keras on your local machine or GPU very easily. Also, we will be exploring some advanced machine learning techniques like data augmentation and transfer learning to further improve our model's performance. We will be learning the engine behind Keras TensorFlow, or more specifically, low-level TensorFlow. Typically in Keras, we're designing the deep learning model at the layers level, but in TensorFlow, we're actually building the computational graph behind the model. In order to take the most out of deep learning, you will need to know how to use low-level TensorFlow, since it will provide you with the most flexibilities for designing complex architectures and distribute the training. Also in this section, we will be learning different methods and approaches to distribute the systems like data and model parallelism. By the end of this section, you should be able to utilize low-level TensorFlow and Keras to train and evaluate your distributed deep learning model on your GPU.
In the final section, we'll take all of what we've learned throughout the course and apply that in the cloud. We'll use Google Cloud's ML engine, which will allow us to do distributed training, hyperparameter tuning, and deploy our model to the cloud. So the first thing we'll do is train our model using 4 powerful NVIDIA GPUs in the cloud. This will drastically speed up our training time. From there, we'll use Google Cloud's Hypertune, which allows us to specify a range of hyperparameters, such as batch size or learning rate, and a target metric, such as accuracy or precision, and then it'll give us back those optimal parameters that we can use in our deployed model. After we finish tuning our model, we'll then launch V1 of our model as an inference engine. So after we have that ready, we'll see that we'll get very fast predictions, but we'll also notice that we're using auto-scaling and a serverless technology, which means that we don't always have a machine available to us only upon request. So our first prediction request will take a long time, but every prediction after that will be very, very fast. So we'll solve that problem by using manual scaling, where we'll make sure that we always have at least one compute instance available for prediction at all times. So we'll get rid of that problem and we'll launch version 2 of our model. From there, we'll then wrap our model in an API using Google API Discovery Services. Now we'll have a production level API. By the end of this section, you will be able to do distributed training and hyperparameter tuning in the cloud using optimized distributed techniques. You'll also be able to deploy your model as a production level API that other systems can easily make requests to.
After the course, You should be able to add Keras low and high-level TensorFlow, as well as Google Cloud Machine Learning Engine into your deep learning tool belt. Moreover, you should be able to solve problems with large datasets and complex model architectures, and deploy your model at scale.
We'll see you there.
See you!